Hello everyone, this is Professor He. Nice to see you again. The topic of this task is about the minimizing the compression work. For the one-stage compressor, the reversible adiabatic compression requires the maximum work, and the isothermal compression requires the minimum. The three processes are also plotted on a TS diagram in the figure for the same inlet state and exit pressure. The reversible adiabatic compression reaches the maximum temperature, and the isothermal compression maintains the minimum. It is clear from these arguments that cooling a gas as it is compressed is desirable, since this reduces the required work input to the compressor. However, often it is not possible to have adequate cooling through the casing of the compressor, and it becomes necessary to use other techniques to achieve effective cooling. One such technique is multi-stage compression with intercooling. The gas is compressed in stages and cooled between stages by passing it through a heating exchanger called an intercooler. Ideally, the cooling process takes place at constant pressure, and the gas is cooled to the initial temperature T1 at each intercooler. Multi-stage compression with intercooling is especially attractive when a gas is to be compressed to very high pressures. The effect of intercooling on compressor work is graphically illustrated on PV diagram in figure 9.15 for a two-stage compressor. The gas is compressed in the first stage from P1 to an intermediate pressure P2, cooled at constant pressure to the initial temperature T1, and compressed in the second stage to the final pressure P3. The compression process in general can be modeled as polytropic, where the value of N varies between kappa and 1. The marked area on the PV diagram represents the work saved as a result of two-stage compression with intercooling. The process passes for single-stage isothermal and polytropic processes are also shown for comparison. The size of the marked area varies with the value of the intermediate pressure P2, and it's of practical interest to determine the conditions under which this area is maximized. The total work input for a two-stage compressor is the sum of the work inputs for each stage of compression, as determined from equation 9.53. This is equation 9.58. The only variable in this equation is P2. The P2 value that minimizes the total work, maximizes the work saved, is determined by differentiating this expression with respect to P2 and setting the resulting expression equal to 0. We then have this relation. That is, to minimize compressing work during two-stage compression, the pressure ratio across each stage of the compressor must be the same. When this condition is satisfied, the compression work at each stage becomes identical. The compression work at each stage should be identical with the optimum pressure ratio and with one or more intercoolers. One compression intercooling process. More compression intercooling process. The optimum pressure ratio for each stage with intercoolers more than one is. The limit of the multi-stage compression with intercoolers is the isothermal compression. More stages result the compressor system complex, high cost, poor reliability. Generally, 2 to 4 stage compression is used. Okay, that's all for this task. Thank you very much and see you next time.